Okay, everybody, welcome to our next math lesson in Module 2. Specifically, we are in Module 2, Lesson 3. As a reminder, please write down the notes with me. Writing down is a good way to learn. When you write something down, you're more likely to remember it. So, Module 2, Lesson 3 today, taking notes with me. Module 2, Lesson 3, the title is Translating Lines. Not translating lines of dialogue, translating geometric lines. And so you will need pages 21 through 29 in your Module 2 book to get started working with us today. But on our notes, let's talk about the road so far. What have we learned so far in Module 2? Well, we learned that there are 3 types of transformations. 3 types of geometric transformations or changes that keep congruence. 3 types of transformations that keep congruence. And remember, congruence means same size and shape. So there are 3 types of transformations, 3 changes, 3 geometric changes where size and shape stay the same. These are the slide, the flip, and the spin. 3 changes where size and shape stay the same. That's what we learned in Lesson 1. Yesterday in Lesson 2, we learned that slides are actually called, the technical term is translations. Translations are the same as sliding a shape. And we also learned that translations have to follow rules. After all, math is a science, and we need to be precise. And to be precise, we need rules. And the rules that translations follow are called vectors. And remember, a vector shows direction with it. It's like an arrow. It shows what direction. And the length of the vector shows the distance of the slide. So the vector is the rule that shows direction and distance, shows where to go and shows how far. Direction shows where, distance is how far. So the vector is the translation rule, I like to say. Today we're going to do some more practice with translations because we're going to practice your skills at using those transparencies, making those observations, more practice with translating. But this time today, we're going to focus specifically on lines. So we're going to be talking about translating lines today, which you knew from the title of the lesson. Now, there is one concept that we need to review to help you get the most out of this lesson. One concept that you've seen ever since elementary school that you are going to see again today. It is the concept of parallel. It is a familiar word. You've seen it before. Parallel. The definition of parallel, you might already know, but we're going to review it because it will happen. It will come up today. Parallel describes lines that will never touch, or lines that will never, mathematical term, intersect. 2 lines that will never intersect, even if they continue forever. Two lines that will never intersect even if they continue forever. Always a drawing works with this, so those are parallel lines. If they keep going, and I show you they keep going with arrows, they will never cross, they will never intersect. A quick way to remember the definition of parallel, I like just to use the word parallel, because parallel is, the definition is like the L's in parallel. If you look at these L's in the middle of parallel, right there, two lines that do not touch. That's what parallel means, and it is hidden inside the word. So that is a little bit of a trick. So let's remember that definition of parallel, and let's practice our translating skills starting on page 21. So set your notes aside, someplace where you can still see them just in case, and let's look at exercise 1 on page 21. It says, draw a line passing through point P, so we have to go through point P, that is parallel to line L. Draw a second line passing through point P that is parallel to line L and is different from the first one. What do you notice? Okay, so let's start by drawing a line that's parallel to line L. I'm going to use a ruler to make sure I stay parallel and to make sure I do a straight line. So this is my line. It passes through point P. Check. It is parallel with line L, means it will never touch line L. Check. Good. First sentence done. Now the next one is draw a second line. Draw another line that goes through point P and is parallel to L. So I need to go and do another line touching point P, parallel with L, and that's it right there. So it's a second line. I have two lines. It passes through P and is parallel to L. Check, check, check. And it is different. I showed it was different with two different colors. It is different. Check. What do you notice? What do you notice about the two lines we drew? Well, you should have noticed that it's the same line. L1 equals L2. If I call the red line L1 and my green line L2, you see that these are the same line. L1 equals L2. Which should tell you that there's only one line that is parallel and goes through this point. It's the same line. I just drew it twice. So a little bit of practice with parallel, a little bit of practice with some theories. So let's do number 2, practicing translating. So make sure you have your transparency near you to help you. It says translate line L with the vector with the rule AB. What do you notice about L and the image L prime? Okay, so I need to translate line L along the vector. So the first thing I'm going to do, here's the vector here. Here's vector AB. I'm going to stretch vector AB like I did in lesson 2 to make sure that I follow the correct direction. So I stretch it out a little bit. Next, I'm going to get my transparency, so I'm going to wiggle it so you can see I have one, because it is clear. And what I'm going to do is I'm going to take my dry erase marker. I'm going to copy the line I am translating. So this is the line I am translating, line L. And then I need to copy my rule also. So I'm going to copy the vector AB, which is right there. Now I'm going to translate. So I'm going to follow the direction, which is the pink dotted line, and the line goes that way. And then I'm going to move my vector and the transparency so that it just touches the vector on the paper, because I have to follow the direction and the distance. So I have to go the exact distance of the vector in the exact direction. What do you notice about the line, the black line on the paper? And that is, the black line is going to be L, and the blue line after the translation is L prime. What do you notice, like the question asks, about L and L prime? You should have noticed that this is the same line. L, the black line, and blue, the translated line, are the same line. Again, L is equal to L prime after the translation. It's just the same line. We just slid it down a little bit. Hopefully you are getting some practice with translating using the transparencies, because these skills will come in handy later. Let's go to page 22 and see what other translating fun they have for us. It says line L is parallel to vector AB. So line L and vector AB are parallel. Now I need to translate line L along vector AB. So I need to move, slide, translate line L. So the first thing I'm going to do is I'm going to look at my vector, and I'm going to extend the vector to make sure that when I do the translation, I keep the same direction. I'm just going to add some pink dotted lines following the arrows to make sure I go the right direction when I translate. Next, I get my transparency and I start tracing. So my vector is right here, AB. The line I am translating today is line L right here. Now line L is moving that vector. So let's start the translation. Let's start the slide. I follow my pink dotted line direction, and I move exactly one vector, which is right there. So now I'm going to actually label this vector on the page so that I'm going to kind of try to write underneath the transparency. A little bit tricky. It does take some practice. But there it is. So after I follow the vector, here is L prime. So this is L, the black line, and our new line is L prime, the one I translated after following the vector rule. What do you notice about L and L prime? What do you notice? Take a minute to write down what you notice. Hopefully you notice that, again, it's the same line. L equals L prime. And the reason is because the line moves in the same direction as the vector. The line and the vector have the same direction, so it's just going to make the same line. Let's be a little bit more tricky. This time let's have the vectors move in a different direction. This time you can see that we have line L and we have vector AB. So we need to translate this. So let's translate line L using the rule AB. And this time we're going to get something different. It's not going to be the same line, because the vector and the line are moving in different directions. Let's see what we get. Again, the first thing I'm going to do is I'm going to make the vector a little bit, I'm going to extend the vector to help me have a good plan for direction, to help me with my direction. That just points me in the right direction. Then, lucky transparency, trace the vector AB, trace the line I am translating, line L, and then when everything is traced, I do the translating. So let's slide following the vector direction. So the vector direction goes up the page. How far do I go? Exactly one vector and no more. So I need to stop right there because that was the vector rule. I follow the direction, I follow the distance. Now I need to I'm going to put 2 points under the ends of the line. Takes a little bit of work. I'm not ambidextrous, so it takes a little bit of effort. That looks good to me. Now I'm going to use my ruler to connect the 2 points I made. And that green line is L prime. So I translated it exactly where it should have gone, and I have L prime. Now, the question, what do you notice about L and L prime? Write down what you notice on your paper. Hopefully you noticed that, hey, these L and L prime look like parallel lines. So L and L prime are parallel. L and the image of L are parallel. Another way to write this, L is parallel to, just 2 parallel lines like that, to L prime. This in the middle right here, that is the symbol that means parallel. L is parallel with the image of L. So we just made parallel lines. So we're learning a little bit more about parallel, and we're practicing translating. It's a good day. Let's go to the next page and see what we have. Page 23 says, line L has been translated. Oh, I don't get to play with my transparency here because they already did the transparency. Here's the original L, and here's the image of L after the translation. So what do you know about L and the image of L? Well, what do you know? Exactly what we found out in number 4 when the vector moves in the opposite direction. We know that L is parallel with the image of L. L is parallel with L prime. Just look at them. You can tell, you know they're parallel because everything is exactly one vector away. A is exactly one vector away from B. If I do 2 more points, C is exactly one vector away from D. They are always exactly the same distance away. They are always exactly the same distance away. If these 2 lines keep going forever and ever and ever, they will always be exactly the same distance away. Let's see if we can measure it. Not really exact in inches. Let's see if it's an exact centimeter distance. Okay, it looks like it's about 3.3 centimeters apart. So that means they are always 3.3 centimeters apart. 3.3 centimeters here, 3.3 centimeters here, 3.3 centimeters here. If I go 5 miles away and keep drawing them, it will always be 3.3 centimeters apart. That is parallel. Number 6, bottom page 23. It says translate L1 and L2. I get to translate 2 lines. I'm going to translate L1 and L2 following vector DE rule. And I'm supposed to label the images. So let's do this. First thing, always remember, stretch out the vector a little bit so that we keep the right direction. We want to go in the right direction, so stretch out the vector a little bit to help you follow the right direction. Next, we trace on our transparency. So there's the vector I'm going to follow. And I need to translate two lines. Line 1 and line 2. And I'm going to follow that vector. Okay, so let's go in the right direction following my pink dotted line. And how far am I going to go? I'm going to go exactly one vector away, which is right there. Now I need to label the images. So let's do L2. Let's do, oops. This is a little bit tricky. L2. Let's do L1, which is going to be right there. And let's do L1. Super tricky. Hopefully you're a little bit better than me at this. There we go. So let's connect the dots. Where did L1 go after the translation? This is the image of L1. And this right here is the image of L2. So I just translated two lines. And now we're ready to answer the questions. We followed the vector, we slid the lines over. The question says, if L1 and L2, if these are parallel, L1 is parallel to L2, what do you know about the translation? What do you know about the image of L1 and the image of L2? Well, if the originals are parallel and they both get translated exactly the same way, the originals are parallel means the translations should also be parallel. So the lines stay parallel even after the translation. Some fun stuff, practicing some translations, getting some easy questions about parallel because this is stuff you can see if you draw it correctly. The lesson summary is on page 24. Lesson summary says, two lines in the plane are parallel if they do not intersect. So parallel means do not intersect. Translations map parallel lines to parallel lines. That means parallel lines are still parallel lines even after translations. If the parallel lines are start parallel, they will end parallel after the translations. And then given a line L and a point P not on L, there is one line passing through P and parallel to L. That's like exercise 1 where it ends up just being the same line through one point. Your exit ticket is page 25, but you're going to do your exit ticket for evidence of your learning later. So set aside page 25, and page 27 is your homework helper. And the homework helper continues to page 28, so you can use the homework helper for help on the if you need some help reviewing the concepts. But let's look at the problem set for some more practice. I like this problem set. I like at least the first question because I don't need to use my transparency to translate these because it's on a graph. The graph means you don't really need your transparency. Let me show you why. It says I need to translate 4 things. I need to translate angle XYZ. I need to translate point A. I need to translate point B. And I need to translate rectangle HIJK. And I use my rule for all 4 of those is vector EF. So vector EF is going to slide all 4 of these. And now I need to sketch the images and label all points using prime notation. Now I'm not going to use my transparency. Let me show you why. Because let's find the vector. Here's vector EF. Now the great thing about graphs is instead of on the transparency, I just count how it moves. So remember, it's vector EF. So we start with E. Now, E, the rule for this vector on a graph means I go up 2 units. So the rule is up 2 units because it goes -1 to 0, 0 to 1, that's 2 units. And then to go to F, I go left 4 units. Do you see how that's my rule? Up 2, 1, 2, left 4. That's my rule. And so I can follow that rule for all of the things because that is my vector rule. And that makes translating on graphs super simple. Because let's start with point A. Point A is right here. I have to follow the vector rule when I translate. What's the vector rule? Well, I go up 2 units and left 4. So let's go up 2. Looks like A is at half. So I go 1.5, 2.5. And then I go left 4. 1, 2, 3, 4. So A prime is going to be right there because I follow the vector. If you don't believe me, you can trace the vector on a transparency. Just trace the vector like this. And then what you should also do is you should also put where the origin is. So put a little X right there so you know it stays straight. Then find A and make sure that it moves, like right there. So you can use your transparency if you want, or you could just use the vector rule up 2 and left 4. For point B, I need to follow the same vector rule. Up 2 units, 1, 2. Left 4 units, 1, 2, 3, 4. And this is where B prime is. You don't believe me? Use our transparency with the vector on it, and you can see it works. Copy the vector. B follows the same vector. Let's do angle XYZ. To do XYZ, I'm going to move X, Y, and Z separately and then connect them later. So X goes up 2, 1, 2, left 4, 1, 2, 3, 4. So this is going to be X prime. Y follows the same rule. Remember, the vector is always the rule. Up 2, 1, 2, left 4, 1, 2, 3, 4. So here is Y prime. Z might be a little bit tricky because Z is not exactly on an intersection of units. So it might be the best strategy for Z to use the transparency vector. Or you can just try to eyeball it, but remember we want to be precise. So if I use my transparency vector, it looks like Z prime moves right here. Then, after I translated the points, I can connect them to rebuild my angle. I connect them to rebuild my angle. And I know that translations do not change size or shape. So if the original angle is 38 degrees, the new one also has to be 38 degrees because translations are rigid motions. They do not change size and shape. I have one more thing I need to translate, and that's the rectangle. I just follow the vector rule, or you can, if you really like the transparency, you can use your transparency to move all of them. I find it easier on graph paper to use the vector rule, but you can use whatever strategy you want today. J moves up 2, left 4, so there's J prime. I moves up 2, left 4, so there's I prime. K moves up 2, left 4, so that's K prime. H moves up 2, left 4, so that's H prime. And then I'm just going to do it freehand to save some time. I would recommend being more precise with the ruler. But there's the image. So now everything has been translated using the vector rule or the vector on the transparency. Some good translation practice there. Hopefully you did along with me. Now we're ready to answer questions. Oh, well, number 2 we already answered. What is the measure of the translation image of angle XYZ? It is 38 degrees. And you should write now, because translations are rigid motions. They do not change size or shape. And now it says connect B to B prime. So let's draw a line connecting B and B prime. So right there, that is our line connecting B and B prime. What do you know about B prime and vector EF? What do you know about this line, this red line, and the vector? What do you think about those? What do they look like to you? Hopefully you noticed they are parallel. Next question, question 4. Connect A to A prime. So draw another line. We'll use green this time because my A is green. Connect A and A prime. Right there. What do you notice about A prime and vector EF? What do you notice about the green line and vector EF? Here's vector EF. I'm going to do vector EF in pink so you can see it a little bit better. Hopefully you saw that these are also, well, not also parallel, sorry, misspoke. These are the same line. It makes the same line because A is on the vector, so it makes the same line. And then 5. Given that HIJK is a rectangle, what do you know about HI and JK and the translated segments? Well, let's look at HI, JK. If you notice, all of these segments, HI, JK, HI prime, JK prime, all of those are parallel. Some fun work on this, some fun drawing, some fun observations. Hopefully you had fun too. Now it's time to show me what you learned with today's exit ticket on page 25. Number 1 says translate point Z along vector AB. So here's your vector AB. They want you to move point Z on that vector. So show me you know how to translate. Please draw it for me and then tell me what you know about vector AB. And when Z gets connected, when you make Z prime, what do you know about AB and Z prime? And number 2, using the above diagram, what do you know about the lengths of Z prime and AB? What about the lengths of those two segments? So what do you know about the two segments themselves for number 1? What do you know about the lengths of the segments for number 2? And then number 3, A and B are on line L, and there's vector AC. So we have vector AC. Translate line L. So you're going to slide the line following vector AC. What do you know about L and your new L prime after you make it? How many other lines can you draw that will have the same thing? And how do you know? So do your best on those exit tickets. Remember, you can always reach out to me, ask me for some guidance, ask me for some help, and I'll be happy to help you out. But do the best you can today. Study your notes, get some extra practice in, and we'll have more fun with translating lines and other objects later on in the module. Have a good day.